Joining us again is Gareth Johnson, the Senior Cloud Architect at J2 Innovations. He is going to be joined by Radu Racariu, who is Senior Programmer at J2 Innovations, and they will be discussing Working Group 798, which is Haystack JSON Encoding. As always, please post any questions in the chat, and I will shoot it over to you, Gareth. Thank you.
Okay, thank you very much. Right, so welcome again. It's nice to be back here at Haystack Connect. And tonight I'm going to be discussing with you Haystack JSON encoding. And I'm really pleased to be joined by one of my colleagues from J2, Radu. So let's go straight into it. So on the agenda, we're going to be covering what the existing data encodings are and have been in version 3. Then we're going to go straight into the new encoding, the new JSON encoding, touch on YAML. Now, obviously, it can be a little bit dry kind of talking about JSON encodings and so forth. So that's why we've got some extras for you. We've got some extra demos, and we've got some JSON schema as well to kind of show you what you can do with Haystack JSON, because we believe, it really kind of opens up the web, makes the data more accessible. So we've got some great demos of that in action. So let's talk about the Haystack version 3 data encodings. So we have Zinc, first of all. So Zinc is for Haystack data. In fact, if you remember yesterday when I was talking, if you were at the Haystack core talk, I was talking about the simple granular types that you have as part of Haystack. So you have things like refs. In this case, you can see on this dict that I'm seeing here, which is an object, you can see that there is an ID tag, and you can see the @ symbol on ID. That's actually a ref, okay? And then we've got area, and you can see it's 1,000 feet squared. And you can see that a number has units there as well. The nice thing about Zinc is that all of the granular Haystack types are first-class citizens, and actually you find that theme quite a lot. We have a display name as string, and obviously I guess the nicest one of the lot there is site. You can see site right on the end there, which is, it hasn't got a colon or anything after it. It just denotes the fact that it is a marker tag. So Zinc is custom made for Haystack. It can't be used outside of the Haystack community, but it is nice to read. It's very precise data encoding, but it's not something that is beyond the Haystack community. So it depends kind of what you like there on what you want to use. Alongside that, we've got Trio. So Trio is more of a kind of human readable take on Haystack data. Again, it's using that concept of those granular types, those small granular types of those Haystack types having their own encoding format, being first-class citizens, pardon me, in the encoding. So here, for example, you can read ID, area, we've got a display name. It's basically just a standard site list. You can add comments to Trio as well, which is nice. And it's more of kind of, you can put your data in it, but really it's a nice way to kind of write documents. So again, this is proprietary. It is, part of Haystack. It isn't used beyond Haystack. Again, very useful, and looks really nice on this screen. And finally, we have the older JSON encoding format. So I've got a grid here. And typically with JSON, what you do is that you just use a JSON parser to parse your JSON, and you get your JSON objects back. But with this particular JSON, you actually have to do some extra parsing. If you look at that dict in the row along the bottom here, if we look ID, you can see ID is a string, okay, and its value is r:id. So when you've used a JSON parser, you then also have to parse out the fact that, hey, there's an R and there's a colon, so it must be a ref, okay? But that takes some extra work. Even a number's not a number because we've got the units embedded in it. So we've got area, n:1000, and then you've got the units after that. So throughout this, even though it's JSON, you still got this extra work to do. And that's a real issue, because that means even JSON actually still requires some form of a custom parser. And that's, I guess that's not so much of a problem with Haystack, with the plethora of libraries out there for working with Haystack data. But it does raise the bar for developers, and it affects data accessibility. And it's the data accessibility and opening up Haystack data to all the different parts of technology, which is really what we're trying to do. So we want to lower the bar. We don't want to raise the bar. You know, as a software developer, when I come across a new standard, it's nice the fact that I can use JSON, or, you know, as imperfect as it is. After all, it's just a subset of JavaScript. It's a standard, and it's easy to work with. So it's important that as the standard gains in complexity and gets more new features like defs, for example, ontology, everything like that, it's important we lower that bar and not raise it. So that's one of the reasons why we created Haystack JSON. Now, it used to be called Hayson, okay, but since it's been adopted as kind of the standard way of doing JSON encoding on Haystack, it's just called Haystack JSON. And the working group 792, there's no third-party library required with working with Hayson data. Now, you can still do it. If you saw my presentation yesterday, we presented a new open source library called Haystack Core libraries. And in those libraries, you can actually use Hayson as a first-class citizen with that framework, which is really, really nice. So you don't have to use something like a TypeScript class like hstr. You can just use a JavaScript string. It's nice and easy to use and work with. So we've kind of embedded it in that API to make it as easy and as accessible as possible. You can look at the spec for Hayson. It's on GitHub. So in fact, you can just go to github.com/J2in, and there you've got all the Haystack Core TypeScript libraries, and it also gives you the specification for Hayson as well. So let's go through Hayson quite quickly, and then actually Radu will show you some really great stuff at the end. So so simples. So a string in Hayson is just a JSON string. A Boolean is just a true or false Boolean. A number can be a number, or if it's got units, it gets broken out into an object. And that object has a val, which is actually a number. So it's there for you to use. You don't need to break that down any further. And then you've got the optional units on the side too. You'll notice one thing which kind of stands out is that underscore kind number. So with just about all the core Haystack data types, you have the kind as a signifier, and that number there kind of matches the symbol name that you have in defs, by the way. The reason it's underscore kind is because underscore as a first character is not a valid character for a tag. It also makes it kind of pop out and stand out to you as well when you're working with it. So this was kind of discussed on the working group a bit. We think actually it's quite a good fit, and it kind of does kind of tell you the sort of data that you're working with. We can continue this convention elsewhere. So we have marker tags. Just quite simply, the kind is marker as an object with its kind as marker. And then we have a ref with an optional display name. Again, you know, I'm not going to go through every single data type in Haystack, but it follows, you get the idea. It follows those simple rules of with everything being kind of in its simplest form to work with. So one thing that really did work out well and really does transform Haystack data is the use of dicts. So with a dict, you have, this is a dict I've got here, it's just a JSON object. And I don't need to have the underscore kind. The reason I don't need to have the underscore kind is because the absence of the underscore kind for an object means it is a dict. Okay, now I can still have that in there if I want to. But what that actually means is that, you know, nearly all normal JSON objects, just forget about Haystack for a moment, but any normal JSON objects actually is also valid Haystack data. Okay, and that's key. You don't need to transform that data from one format to another. If you've just got a JSON object, or you can see a list is just an array, you can just work with it, which is great. Of course, you can combine that in with the other data types that we have here. So you can see I've still got a site marker tag as an object here. I've got a number without units, so I can use a number. A Boolean is a Boolean, but it's just nice and simple and easy to work with. This is a grid, just to give you an idea of what a grid looks like. You can see that the rows don't require that extra decoding. I don't need to use a third-party library there to take that data apart and drill into it any further, which is really nice. One thing, I mean, I work on the cloud application, so I'm a cloud architect. And I work with YAML files quite a lot. So I don't, although, you know, we do stuff with JSON, which is just fine. You know, I actually work with YAML, which is a human readable format. So if you think about this, if we've got Hayson, that's kind of like the open equivalent of Zinc. And then I would say YAML is kind of the equivalent of Trio. And in fact, YAML actually works as a very good substitute for Trio as well, which is really nice. You can see here I've lost the curly braces. Is actually the same data as you saw in the last slide there. It's just in YAML. Okay, so you know, not over exciting, you know, when we talk about JSON schemas. So that's why we wanted to add a little bit more spice to this presentation, as we like to do. So we've got some JSON schemas we created as well, and this is really useful for writing out Hayson data using an editor, or in fact working with web services where you know, when you create a REST API and you've got your business logic endpoint, it's really nice to have the data validated before it actually reaches that endpoint, right? So there's some really good use cases that are solved by the use of JSON schema and Open API schema. So with JSON schema, we've registered that schema with schemastor.org, and you can use Visual Studio Code to actually, or in fact, any of the world's major IDEs really kind of support this now. By just renaming your file hayson.yaml or hayson.json, actually the editor will start parsing that out and you can work with that data. So actually I'm going to show that right now. I've got Visual Studio Code. Now I've got a couple of examples here. This is Hayson here. So I've got grid.hayson.yaml. And I've pushed these examples to the Hayson repo. So again, if you go to github.com/j2in, go to the Hayson repo, you'll see those examples. So I pushed them earlier today. So this is a grid, and you can see we've got 2 rows. What I'm going to do now is I'm just going to modify this a bit. You can see the number I've got down here. First of all, I get autocomplete here, which is really nice. If I change that to a string, this particular value, oh, expected a number. Isn't that nice? You've actually got proper IDE support for Haystack data, even down to the date time, for example. If I try and put in an invalid date time with a silly number in it, or actually use a regular expression and make sure that that's all good. So this is actually very useful. You can add the comments there. YAML's got lots of features. There is supported in virtually all the world's major programming language, major popular programming languages out there, so you can just kind of work with it, which is really nice. And you can add comments. It's got some advantages over Trio with kind of the way it can handle new lines in multi-line strings and nice, and some other features too. I don't think any of these technologies are perfect, but they are kind of used by everyone. So it just goes without saying that it's one of those things we should try and use if we can. I've also got another example where I've taken part of the defs library and I've just translated it over to being Hayson YAML. And I can compare this with the, I didn't have it open, the repo I was going to have it open with. But anyway, this is just giving you an example. There's actually defs here that I've got encoded here. You can see it's very simple and straightforward. This is just one of the core defs file here. One thing I did want to point out, I forgot to open up the other file that actually had it in. Actually, I can probably just do it. Trio, there it is. I can do it. Good old VS Code. This is the Trio version, okay, and this is the Hayson version. So you know, there's no doubt that, you know, for marker tags and things like, you know, Trio is better. So it does kind of depend on what you want to do. They're both good in their own right. But it is nice to have color encoding and error checking and completion and stuff, isn't it? Especially if you're working with lots and lots of data. It's nice to have that in the IDE. So I'm going to leave it there now, actually. And Radu's going to talk a bit. I'm going to hand over to you now, Radu. You're going to talk a bit about performance and your demo.
Yeah, sure. So we did a bunch of benchmarks before, and as it shows the difference in performance, especially when you have a native JSON parsing, it's quite considerable. We use the Haystack core libraries that Gareth presented yesterday, and as you can see, the difference is quite considerable. The same goes for the data size, even though the Zinc format is quite compact and more terse. When gzip compression comes into place, the differences are not that big anymore. So even though there are some size compromise happening over here, the performance, especially when the native JSON parsers comes into place, it's quite substantial. So I'm going to dive into a demo I want to present today that highlights the importance of having an open format such as JSON for data interoperability and how it actually helps opening up Haystack to a more wider audience and potential consumers. So for that, I prepared for today a sample OpenAPI service. This fictional service is a simple service that basically returns time series. And because we support all the nice schema definitions, we can actually embed it in the service definition, and this will provide validation because OpenAPI and Swagger in this case can actually generate stub services for you. Using the schema definitions, it helps in making sure that whatever you return or
sorry, Radu, are you sharing your screen? I can't see it.
Yeah, just a second.
Sorry.
Yeah, can you see now?
Yep, all good.
Yeah. So in this case, the service I'm talking about, it's returning a time series. As you can see, there is the nice thing about the editor is that it's actually allowing you to have a view of the examples formatted, and you actually can drill down on the schema and see what exactly is expected to be returned from the service. In this case, it's just a grid with the timestamp values. So because we have this open standard, I can go to a new web-based service that allows me to import the definition I just showed you before and create a mock service for it. And this will create the endpoint for me, which is the series. I have the routes for the service together with the data I have over here. So now having this, the quickest way to show you how powerful that is that using another open tool for the web, I was able to consume the data that comes from the service itself and display the data I have that is a time series as a chart using an open source chart component. And this shows how important it is to have data available as an open format, because without actually using any outside parsers or other technology, just using the data itself, I was able to consume it in a meaningful way. In this case, displaying it as a chart. So you can see that the value added here it's quite big, especially when it comes to data interoperability. So this is what I have for now for this. Our slide contains the links for the demos, so you can play with that. And yeah, that's about it. Thank you.
Thank you, Radu. I mean, the really cool thing there is that, you know, you're using all very visual tools. They're using open web technologies to deliver something visual, which is really nice there. And I think with that Swagger editor, actually, Radu, could you go back to your first tab there? We use actually this for all the REST APIs that we create. So one thing, you know, we have ops in Haystack data, but something that we like is just, you know, I guess we're just a little bit more traditional. We're actually creating REST APIs with Haystack data. And so, you know, by using this technology, you can actually validate all of that Haystack data before it reaches your endpoint. You can see this is actually a really nice way to visualize your REST API endpoints using this technology. And all of this is free. All of this is open source stuff. It's just, there's nothing hidden on there, which makes it really, really powerful. So I'm going to just share just my screen on just the very last slide, because I missed that one out. So I'm just going to, Radu, could you stop sharing and I can just, actually, you don't have to, I can actually just copy the code examples there. So I'm just going to just wait for you to stop sharing. Oh, no matter. What I'm going to do is oh, there we go. So I'm just going to post this. I missed out the British pun, which is a real shame, but never mind. We've got some links down the bottom here. I'm going to take these links here and I'll put them on the meeting chat here, so you can actually load them. We are actually going to also, everything you see here, we're actually put in a repo on the J2In GitHub repo. So you'll have all this information so you can play with it, because we want it to be interactive. These sessions are quite short, so we wanted to make sure that you could take this and do something with it beyond the session. That's all from us. So I'm going to hand over now to Corey.
Well, actually, we had a couple questions, if you don't mind sticking just for a minute.
Cool.
Is it in the new standard, the Hayson JSON and YAML? I'm not saying that right, probably.
No, you got it right. That's fine. YAML, tomato, tomato. Yes, it is in the new standard. It is part of Haystack 4, and that has been also, if you recently, the Project Haystack website has just been updated, so you can see the version 4 and 3 there together.
Okay. Is what you share with us today equally as effective for a building with a small footprint as well as one with a large one?
Yes, I mean, it's kind of, it will work with either, you know, it's appropriate for any sort of data, really. So it will work with either, you know, a large building or a small building. It's, you know, it'll work with either. The nice thing about working with this data as well is that there are plenty of other encodings that can take like JSON and kind of shrink it down to kind of binary JSON encoding and other things there. So, you know, there's lots of different ways to use that data and transform it, which is really nice. But yes, it'll kind of work across board.
Okay, and that's also true of the type of building, like retail, commercial office, data center, light industrial.
Yeah, I mean, it will work with anything.
Good. Good. Can you tie the role Hayson JSON plays in conjunction with the Haystack core shown yesterday, all open?
Yeah, so it fits in really, really well with the Haystack core library I showed yesterday. So in Haystack core, you have you know, a representation of the core data types. So we have hstr, we have hnum for number and so forth. The nice thing with Haystack core is that it naturally uses Hayson to a great degree. So you can, if I'm creating a dict, for example, I can actually create an HDict with Hayson, which is nice. If I call to JSON, it will give me a JSON object back from that as well. If I call JSON.stringify, then I can create a string version of a Haystack object, and it will be encoded in Hayson as well. So it's a very, very natural fit. Actually, that was one of the core things that came out when we started creating Haystack core, was kind of Hayson kind of fell out from that as that development, because we wanted a simple way to work with Haystack data. And so it's nice having these like TypeScript classes and stuff, but it's also nice to have the data as well, because if you've got a number, ultimately you want to handle it as a number, don't you? If you've got a string, you want to handle it as a string. So we made the library kind of work with both seamlessly.
Okay, and I have one last question for you, which is, for time series data, is Haystack JSON a good format versus a tabular format like standard CSV?
That's a good question. So if you're working with Hayson, as Radu showed, it actually compresses down with gzip very well. I'm not going to say like it's the perfect format there. I think kind of a tabular format like Zinc, for example, works quite well. But when you actually factor in how well it compresses down using a gzip algorithm, and also actually how quickly it parses, the numbers on Radu was showing there were quite significant. So, and those numbers mean money, especially if you've got something like an AWS Lambda function where you're being timed on how long it actually being billed on how long it takes to execute. Time is important. So I would say it suits it quite well, especially when it comes to parsing. That's just a lot quicker.